Difference between equivalence partitioning and boundary value analysis. The difference between equivalence partitioning and boundary value analysis. Definition. Equivalence partitioning, also known as equivalence class partitioning or ECP, is a black box test design technique where test conditions are divided into several groups. Each group represents similar behavior. On the other hand, boundary value analysis is a test design technique or testing that focuses on testing values at the extreme boundaries of input domains. So that is one difference. Difference on the definition. Now, second difference would be data set counts. How many data set can be, test data set can be created. So for equivalence partitioning, I create one set of test data from each group. On the other hand, in boundary value analysis, I create multiple sets of test data from each group depending on how many boundaries are in the group and how many boundaries are in scope. That is the second difference. Third difference, the test data I create, third difference. In the equivalence partitioning, the test data I create that could be anywhere. It could be at the bottom boundary, upper boundary, or anywhere in the middle. On the other hand, in boundary value analysis, test data must be at the boundary. It cannot be anywhere in between. It has to be at the boundaries. That is the third difference. Fourth difference I give with the example. I'll give an example for the fourth difference. Let's say the requirement is users are able to sign up on a particular website where user ID should be between 8 to 12 character. Between 8 to 12 character. User ID should be between 8 to 12 character. That is the requirement. Now first, I will, in the test design technique, I have defined test conditions and then design test cases and specify test data. There are three steps: define test condition, design test cases, and specify test data. In terms of defining test condition, I will divide the input domains into three groups. So on this particular example, where user ID is between 8 to 12 character, so I will divide the input domains into three groups. First group is less than 8 character. Second group is between 8 to 12 character. And third group is above 12 character. So these are the three groups that I have divided the input domains into three groups as part of defining test conditions. That is step one. Step two, I will write design steps or test steps in ALM, Jira, RTC, or Excel spreadsheet, whichever is used by the client. That is step two. And step three, I will specify test data. Now, this is where the difference comes in the equivalence partitioning and boundary value analysis. In equivalence partitioning, I will create one set of test data and I will create it randomly. So on this example, first group is, on this example is users are able to sign up on a particular website where user ID should be between 8 to 12 characters. First group is less than 8, second group is 8 to 12, third group is above 12. So in the first group, less than 8 means 0 to 7. In this group, lower boundary is 0, upper boundary is 7. Now, I will create one set of test data from this group and I will create that randomly. When it is equivalence partitioning, then I will create randomly. So from 0 to 7, 0 is out of scope. So 1 to 7, I randomly pick a number. Let's say I pick a number 5. I just picked a number 5. Now I will create a user ID which will have 5 character, and then I will try to sign up. System will not allow me to sign up. Then testing pass. If system allows me to sign up, then testing fail. That is from equivalence partitioning. Now, if it is not equivalence partitioning, if it is boundary value analysis, then I will not be randomly pick a number. Earlier, I randomly picked a number 5, but I will not be randomly pick a number. It is not allowed. I have to take the test data at the upper boundary or lower boundary. So in this example, less than 8 character in this group, it starts with 0, ends with 7. Lower boundary is 0, upper boundary is 7. So creating a test data at the lower boundary is out of scope. So, and creating a test data at the upper boundary is in scope. So I will create a user ID which will have 7 character, and then I will try to sign up. System will not allow me to sign up, then testing pass. If system allows me to sign up, the testing fail. So that is from the first group. Now from the second group is 8 to 12 character. In this group, lower boundary is 8, upper boundary is 12. Now when it is equivalence partitioning, then I will create one set of test data and I will create that test data randomly. But if it is not equivalence partitioning, if it is boundary value analysis, then I will create multiple sets of test data, and test data has to be at the boundary. So in this example, lower boundary is 8, upper boundary is 12. In the equivalence partitioning, I create I create one set of test data that I create randomly. So from 8 to 12, 8, 9, 10, 11, 12, from among these numbers, I randomly pick a number. Let's say I pick a number 9. Now I will create a test data which will have 9 character. I will try to sign up. System will allow me to sign up, then testing pass. If system doesn't allow me to sign up, the testing fail. That is for equivalence partitioning. But if it is not equivalence partitioning, if it is boundary value analysis, then I'll have to create multiple sets of test data, and test data has to be at the boundary. So there are two boundaries, lower boundary and upper boundary. Lower boundary is 8, upper boundary is 12. So I'll create two sets of test data. Two sets of test data. One is for lower boundary, other one is for upper boundary. So I will create one set of, for the lower boundary, I will create a user ID which will have 8 character, and then I will try to sign up. System will allow me to sign up, then testing pass. System doesn't allow me to sign up, then testing fail. And I will create another set of test data for the upper boundary. Upper boundary is 12. So I will create another set of test data. So I will create another user ID which will have 12 character, and then I will try to sign up. System will allow me to sign up, then testing pass. If system doesn't allow me to sign up, the testing fails. So this is the difference between equivalence partitioning and boundary value analysis. I have given 4 different. I have explained the difference of the definition. I have explained the difference on the number of test data sets. I have explained the difference on the location where the test data should be created, and then I also given the example. I have given the example. So I have given 4 different types of differences. That is the topic of this tutorial video, to explain the difference between equivalence partitioning, and boundary value analysis. Thank you for watching.